Most years, the inner solar system only welcomes a handful of quiet wanderers, faint comets that come and go without anyone noticing. But this year, something different has arrived. From the edge of interstellar space, a stranger has crossed the cosmic border, older than our sun, faster than anything we've seen before. Its name is 3I Atlas, the third interstellar object ever discovered. A visitor from another star system, wandering through the solar winds like a ghost made of ice and memory. For months, telescopes around the world have tracked its approach, charting every flicker, every shift, every pulse of light. And now, as it draws closer to the sun, something about it is changing, glowing in ways no one expected, behaving like nothing we've ever seen before. Some call it a comet, others call it an enigma, but deep down, every scientist watching it knows this isn't just another rock drifting through space, because the closer we look, the stranger it becomes. It happened far from any city lights deep in the deserts of Namibia. On the southern edge of Africa, there, under a sky untouched by pollution, a group of astrophotographers gathered to capture the lunar eclipse, the moment when Earth's shadow would swallow the moon whole. During that brief window of darkness, when even the brightest stars burned sharper than usual, they turned their telescopes toward a faint object drifting through the black, and there it was, 3I Atlas, glowing a strange, pulsating green. The photos captured that night would go on to stun the world. A visitor from another star system, shining with an alien hue under the shadow of our planet, under the shadow of Earth. One observer wrote, "Something out there began to glow." But comets don't just turn green for no reason. For decades, astronomers have understood why most comets glow green. It's chemistry simple, predictable, and beautifully consistent. The green light usually comes from diatomic carbon, or C2, a molecule made of two carbon atoms bonded together. When sunlight's ultraviolet radiation hits these molecules, they begin to glow a soft emerald halo that wraps around the comet's icy heart. But here's the problem: 3I Atlas doesn't have any C2. Not a trace. Observations from multiple telescopes confirmed it. This object is deficient in carbon chains, the very thing that should make it green. Instead, it's coma. The glowing cloud surrounding the core is filled with carbon dioxide, CO2, and heavy metals like nickel. That combination shouldn't produce a green light at all. It's as if the chemistry of this object was written in a different star system entirely. So if not carbon, then what's making it glow? As 3I Atlas moved closer to the sun, astronomers expected it to behave like any ordinary comet, to flare, to twist, to drift. That's what happens when sunlight heats a comet's frozen surface water ice, sublimates into gas, creating invisible jets that push the comet off balance. The result is a chaotic dance. The comet drifts, spins, and shifts its path a little more each day. But 3I Atlas isn't dancing, it's gliding. Despite venting gas and forming a growing tail, its movement remains eerily steady, shifting by only 1.5 kilometers per day. For comparison, Andrei Borisov, another interstellar comet, shifted more than 100 kilometers per day under similar conditions. It moves, one researcher said, as if obeying a command. The data doesn't lie. Its orbit is almost perfectly flat, unwavering, as though drawn by a steady hand across the solar map. Then came another surprise one that pushed the limits of every theory we had. Spectroscopic readings showed that 3I Atlas was releasing metal into its coma, specifically nickel. That alone isn't unheard of. Some comets do release metals as they near the Sun. But here's the catch. Atlas wasn't anywhere near the Sun yet. When this metallic trace was first detected, the comet was still drifting between Mars and Jupiter, a region far too cold for nickel to evaporate. Naturally, nickel shouldn't evaporate here. One scientist noted, unless it's being burned. The data began to look less like a natural process and more like a mechanical signature. After all, engines made from nickel alloys, like those used in rockets, tend to leave a very specific metallic exhaust pattern. If it's natural, one astronomer whispered, it's unlike anything nature has made. If it's not, someone built it? By now. 3. Atlas had grown a visible tail, a long stream of dust and gas pointing directly toward the Sun. Normally, that's when things start to get chaotic. The heat, the radiation, the solar wind, they all push and pull, sending most comets spinning off their expected paths. But not this one. 3. Atlas kept to its line smooth, unwavering, almost unnervingly perfect. Astronomers ran the numbers again and again, thinking there must be an error. There wasn't, compared to Hale-Bopp, which shifted over 10 kilometers per day, and Oumuamua, which veered by nearly 1,000 kilometers per day. 3I. Atlas was almost motionless, only 1.5 kilometers of deviation on average. It's holding a path so steady. One researcher said quietly, it almost feels deliberate. The question no one wanted to say out loud was the one echoing in every observatory on Earth. What if this course isn't random? As scientists charted its course, a strange pattern began to emerge. 3. Atlas wasn't just passing through the solar system, it was cutting across it at an angle that led directly to the far side of the Sun. From Earth's perspective, that means one thing: we're about to lose sight of it. By the time it reaches perihelion, one astronomer noted, it will vanish behind the Sun. For weeks, our telescopes will be blind, unable to see what happens next, unable to know whether it burns, breaks apart, or changes course, unless the narrator's voice drops low. It decides to slow down. The words hang in silence as a low, distant rumble fades in the sound of something vast. Moving closer. There's one more piece to this puzzle, a story buried deep in the archives of astronomy. In 1977, a powerful radio telescope at Ohio State University picked up something extraordinary, a signal that lasted 72 seconds. It wasn't random noise. It wasn't from a satellite, or the Sun, or any planet in our solar system. It came from deep space. The frequency was 1,420 megahertz, the exact emission frequency of hydrogen, the most common element in the universe. That's why it stood out. If someone wanted to send a message that every intelligent species could recognize, that's the frequency they would use. The astronomer who found it circled the data on the printout and simply wrote one word, wow. Guess which constellation it came from? Sagittarius. And guess which direction 3I Atlas came from? The same. When astronomers traced its orbit backward through time back to the outer edge of the solar system, to the year 1977, something about the alignment made people pause. Maybe it was the first hello. The deeper astronomers dug into the data, the stranger it became. When they ran the numbers, the odds of coincidence that both the WOW signal and 3I Atlas came from the same region of the sky were less than 1 in 100,000. That's not impossible, but it's close. And yet, science has its limits. The data isn't conclusive. There's no solid proof that the two are connected, just the uneasy feeling that maybe they are. If it's coincidence? One researcher said, it's the most poetic one the universe has ever written. And if it's not, he added, then something ancient has finally arrived. Beyond the mystery, beyond the speculation, there's something more profound at play. Every photon bouncing off its surface, one astronomer said, carries the story of another sun. For the first time in human history, we're not just observing a comet, we're watching interstellar dust react to our own star. In real time, whether natural or not. It's teaching us what textbooks never could, that the universe still surprises the brave. On screen, telescopes turn toward the heavens, their mirrors glinting as the faint green glow of 3I Atlas ripples outward like waves in the dark. The night sky has always been a conversation between what we know and what refuses to be known. For all our telescopes and equations, for all the names we've given the stars, we still find ourselves staring into the same endless question. Maybe 3I Atlas is nothing more than ice and dust. Another frozen traveler caught in the gravity of our sun. Or maybe it's a mirror quietly reflecting how little we truly understand. The wow signal begins to echo again, faint, distant, like a memory caught in static. Its 72-second pulse fades into silence, dissolving into the hum of the cosmos. Then, nothing, only a black screen and 2 lines of white text. Stay curious. Stay watching, because something out there might be watching too. The stars fade, but the voice remains calm, reflective, almost a whisper. If you want to be here when it returns to the light, subscribe and stay on watch. The sky is whispering again, and this time, we're listening. The faint green glow of 3I Atlas flickers once more, then fades to black.